Good afternoon, everyone. For our topic for today is about modular construction. I am Kate Bautista together with my partner Marjeline Estrera. Modular construction have the main sectors: attribute types, key technical issues, sustainability, procurement, typical details, and package and interfaces. Let's talk about modular construction. It is a process in which a building is constructed offsite under controlled plant conditions using the same materials and designing to the same codes and standard as conventionally built facilities, but in about half time. It is a term used to describe the use of a factory produce pre-engineered buildings units that are delivered to site and assembled as large volumetric components or as substantial elements of buildings. Also, we have the main sectors of application of modular construction, which are the private housing, social housing, apartment and mixed use buildings, educational sectors, and student resident. We have the K worker accommodation and sheltered housing. We have the public sector buildings such as prisons and MOD buildings. We have the health sectors building, and lastly is the hotels. We have 1,000 of modules are manufactured annually in the UK or United Kingdom. The largest market for modular construction are in students' residence, military accommodation, and hotels. But the health sectors is significant as it requires highly complex service and medical installation that be commissioned and tested off-site. Also, the use of modulars and other lightweight forms of building construction in increasing. The benefits of modular constructions relative to more traditional methods include economy of scale through repetitive manufacture, rapid installation on-site 6 to 8 per units per day, high level of quality control and factory production, low self-weight leading to foundation savings, suitable for projects with site constraints and where methods of working require more of. We have the site manufacturers limited description in the vicinity of the construction site, useful in building renovation projects such as rooftop extension. We have the excellent acoustic insulation due to the double layer construction, adaptable for future extension and ability to be dismantled easily and move if required. Robustness can be achieved by attaching the units together at their corners. Lastly, is the stability of tall buildings can be provided by a braced steel core. Also, we have the features of modular construction, which are the suitable for buildings with multiple repeated units. Size of unit is limited by transport 3.6 by 8 is typical. Open-sided units can be created by changing the floor orientation. We have the modules are stuck with usually no independent structure. Self-weight of 1.5 to 2 kilonewton meter squared. We have the 4 to 10 stories. 6 is usually the optimum. Fire resistance of 30 to 60 minutes provided. Lastly is the acoustic insulation is provided through double layer walls and floors. Also, we have the type of modules. We have the open-sided modules. Modules are manufactured with four closed sides to create cellular type space designed to transfer the combined vertical load of the modules above and plane loads due to the wind action through their longitudinal walls. Depending on the location and exposure to wind action, the height of buildings in the fully modular construction is in the range of 6 to 10 stories. Also, we have the partially open-sided modules, which can be designed with partially open sides by the introduction of corner and intermediate posts and by using a stiff continuous edge beam in the floor cassette. Additional intermediate posts are usually square hollow section so that they can fit within the wall width. Two modules can be placed together to create wider space to compression resistance of the corner or internal post control is the maximum height of the building. 6 to 10 stories can be achieved as for fully modular construction. Also, we have the open-sided corner-supported modules. It can be designed to provide fully open sides by transfer of loads through the longitudinal edge beams to the corner posts. A shallow parallel flange channel section may be used to support the ceiling, but in all cases, the combined depth of the edge beam is greater than four-sided modules. It can be placed side by side to create larger open space as required in the hospital, schools, and etc. Also, we have the mixed modules in planar floor cassette. It is constructed in a similar way to that described for open-sided modules, but the loading applied to the side of the module is significantly higher. Therefore, this mixed modular and planar form of construction is limited to buildings of 4 to 6 story height. It is typically used in residential buildings, particularly of terrace form, comprising modular cores for stairs and highly serviced area. Parang kagaya siya nung Grand Summit and Greenleaf Hotels, mga residential buildings. Also, we have the module supported by a primary structure. So, as you can see in the picture, yan siya. So, in this case, the supporting columns are positioned at a multiple of the modules, normally two or three modules. The beams are designed to support the combined loads from the modules above, normally a maximum of 4 to 6 stories. Also, we have the non-load bearing modules. It is similar form to fully modular units, but are not designed to resist external loads other than their own weight and the forces during lifting. They are used as toilet bathroom units, plant rooms, or other service units and are supported directly on a floor or by a separate structure. The units are designed to be installed either as the construction process proceeds or slid into place or the complete floor. So also we have the stair modules. So it can be designed as fully modular units and generally comprise landings and half landings with two flight of stairs. It can be supported by longitudinal walls with additional angles or SHS members to provide local straightening if necessary. The stair modules rely for their stability on a base on top which leads to use of a false landing. Also, we have the technical issues. We have the dimensional planning, stability and structural integrity, service interfaces, acoustic performance, and lastly is the fire safety. So we have the dimensional planning. We have the cladding requirements, including the element with external dimension of cladding, planning grid for internal fit outs such as kitchens, transportation requirements, including access to the side, building form as influenced by its functionality, repeatability in the modular manufacture. So we have the stability and in structural integrity. So overall, stability is provided by the modules themselves or by an external structure. The load path is through the walls of the 3D units, and so removal of this load path means that the walls should be designed to either span horizontally and can be supported by tie forces to the adjacent units. Also, we have the service interfaces, use of a communal space for distribution of service, use of the floor or ceiling zone. So for service distribution, we have the installation of service within each mode in the factory with site work involving only connection of module. We have the drainage connection of modules connected to the vertical risers in the corner of the modules. We have the wet areas are connected back to back to concentrate service zone. So we have the acoustic performance. So use of two overlapping layers of plasterboard is fixed inside the modules. So it provides a high level of acoustic separation because each module has separate floor, ceiling, and wall elements, which prevents direct transfer of sounds along the members. So, special care needs to be taken around opening for service pipes or other penetration because sound attenuation is particularly affected by air pathways within spaces. Electric sockets penetrate the plasterboard layer, so they should be carefully insulated using quilt attire. So it improves the sound reduction. So we have the fire safety. So fire safety is provision to adequate means of escape to ensuring structural integrity and controlling spread of fire across compartment boundaries. Its modular construction is generally achieved these requirements by the use of fire-resistant plasterboard conforming to BSN 520. Alternatively, materials such as cement particle board and gypsum fiber board may also be used in combination with plasterboard as the facing layer. So as you can see here, we have the fire safety of each. We have the walls and floors. So we have the 30 minutes fire resistance is achieved by a single layer of 12.5 millimeter fire resistance. We have the 60 minutes fire resistance for 12.5 millimeter fire resistant plasterboard on a layer of 12.5 mm wallboard with stagger joints in each face of the cell stud wall. We have the for floors, we have 30 minutes fire resistance for 18 mm groove boarding on light steel joints and 12.5 mm fire resistance plasterboard beneath with joints, tape, and filled. For floors, we have 60-minute fire resistance is achieved with at least 8 mm and TNG board floor finish and one layer of 12.5 mm fire resistance plasterboard and a layer of 12.5 mm wallboard with staggered joints beneath the steel joints. So we have the sustainability. The concept of using sustainability indicators is becoming accepted as part of the environmental assessment of building construction. So, for modular construction, it is appropriate to include whole life measures such as potential reuse or relocation, which are not properly reflected in conventional measures of sustainability. So, at this point, we have the procurement, we have the decision making process. So, decision making process is the close involvement of the client in assessing the business related benefits provided by the method of construction. So, we have the direct involvement of the manufacturer in the design, costing, and logistics. The need to make key decisions early in the procurement process. The important environmental and site related benefits can be achieved. The effects of transportation logistics on cost and module sizes. Also, we have the procurement process, which is the traditional in which an architect provides the design coordination and the general construction provides the construction to coordinations. The module manufacturer as the specialist subcontractor. We have the design and build process, in which the modules manufacturer provides the detailed design and is responsible for its construction. We have the architect may specify the manufacturer who will undertake the detailed design work. We have the alternatively the architect may draft a performance specification of the work. So at this point, Marjeline Estrella will report about this thing.